I have a really quick update here on the Gantt chart. If you're following along on the Gantt chart, now that we're done with the first phase here, we're going to, of course, we're grading them right now, and then we go through a QC process. That hopefully will be released on Thursday evening. And if there are any design issues, what you should do is you should go back and refactor those. Refactoring means that you're changing the code, but not the behavior of the code. So you're changing the design to fix some flaw or something like that. It ran, all right. It was perfectly fine. It output exactly what was expected, but there was some design flaw that they pointed out, that the graders pointed out, that you're going to have to take care of. You'll want to go back and do that as soon as possible once you know about it, or you can go ahead and talk to like an LA right now and see what get their critique, so that you can be prepared for next week when you have to build on that code. Each one of these phases builds in the previous phase. So if you don't have, I don't think that there was an issue with this section, but if you didn't turn in anything, for example, you're dead in the water until you go back and do something, right? Because you're not going to be able to do assignment 3 without having done assignment 2. That's the nature of the beast. These are called sprints. I don't know if I've talked about sprints before, but agile software development is a technique, popular, the de facto technique as far as most people are concerned nowadays, whereby you tackle a project, either a set project, this project is going to be a year, something like that, or an ongoing project, a project that never ends because of maintenance or whatever. You define what are called sprints. So usually it's about 4-week sprints, or 1 month or so. We're going with 2-week sprints. That's not uncommon, but that's not common, but it is heard of. But we're doing that because this is a class. We can't afford 4 weeks, right? Typically what you do is, as a team, because this is self-management, the development team, say 4, 5, 6 people or something, at the beginning they have a planning phase, right? One day where they sit down and say, these are all the things that need to be done, because the owner of the project needs this thing done, this thing done, this thing done. Well, that thing depends on that thing, so obviously we can't do that until that's done. They plan that stuff out and say, in the next 4 weeks, in that sprint, we can commit to this, this, and this, right? And that's your work for you do various things like point exercises and debate back and forth of, that's 40 points, that's 20 points. Well, what's a point? 40 points is worth 5 Stanley nickels, right? It's just made up. It's just a way of being able to organize and have an idea, an estimate of how much work there is, right? Last sprint, we got 120 points done. So if we estimate that this is 50 points and that's 60 points and there's 5 points over there, that's probably all we're going to be able to do, right? It's just a way of estimating things. That's already been done for you because, of course, I had to write the damn assignment, right? And so what you need to do, though, is you need to plan out the rest of your phase and say, yes, this is the things that need to be done in the next 2 weeks. This is how we're going to plan it out. And with your partner or alone or whatever, this day I'm going to work on that. This day I'm going to work on that. Ultimately, what you do in agile software development is you report in, okay, I took this task that was 20 points. That's a 3-day task, right? And so I report that I am, after the first day, I am 33% done with that, right? And the next day you report, well, now I'm 67% done with that. On the third day, okay, now I'm 100% done with that. Or maybe I'm only 90% done and it wasn't a good estimate, right? And then, okay, it's going to take me another half day to complete that and we're done with that. Software is used so that it's keeping track of your progress throughout the entire sprint, and it produces what's called a burn down chart. I think I put that up there, burn down chart. Let's just go ahead and look at an example here, images, right? So here's your ideal burn down, right? Everything should be a nice, constant linear flow so that you're working, at a constant pace. You don't have these days of, I'm doing nothing, I'm just going to go ahead and sit back and do nothing today, right? Versus now the next day, now I'm going to have to double my efforts. Now I'm going to work twice as hard just to make up for it. You don't want to work like that. You want to work at a nice, steady flow, right? Now, unfortunately, some industries like video game development is notorious for not having this kind of behavior. Instead, rushed work right at the end because we've got to deliver the product, whether it's finished or not, right? They don't have, but businesses cannot afford that kind of burnout. And so you want this nice linear control all the way down to 0. This is the work that we committed to. On the 20th day or whatever, the 4 weeks from now, we should have 0 work left. Now, does your actual work match that? Yeah. Right? Some days we did less, right? Some days we accomplished more, but ultimately we kind of followed that nice linear burn down, right? We weren't burnt out, right? We weren't working all at the last minute, right? Where you've got this, we haven't gotten anything done, and then suddenly at the end it drops off. All right, we're done now, right? Because you cram session. You don't want to have, oh, we got everything done on the first day, great, right? Time to go ahead and chill for the rest of the next 3 weeks, right? That indicates bad planning, right? Or good planning if you're on the I'm not going to do anything for the next 3 weeks end of it, right? But that's not how it should be done, right? Because it is self-management, right? You don't have some boss coming in and dictating, drop everything, I need this over here, right? That's bad for planning too. And so the idea of sprints is that once you freeze what you're doing at the beginning of the sprint, nobody can come and tell you, nope, priorities have changed. You say, well, I'm sorry about that, but you should have the priority. You'll have to wait until the next sprint, and then you can go ahead and reorganize our chart. Right? You don't have somebody coming in and screwing up your process the entire time with bad management. Right? It's a way of protecting a development team from bad management by giving them more agency, more of the decision-making process. So you might see something more formal like this in, say, Software Engineering Course 361 or something, but it is how you should approach any work, actually. Right? That's how I approach all my work. Right? Not with a formal burn down chart or anything like that, because I'm not reporting to anybody. I'm just reporting to myself. But you might want a burn down chart to keep track. How many hours a day do I spend video gaming or whatever? Right? How many hours a day do I spend running? Right? I need to up that a little bit more, right? Or something like that, right? And then if you don't know what you're doing, then you can't change how you're doing it. Right? But that's a simple burn down chart right there. It goes along with a Gantt chart, but a Gantt chart predates agile development by maybe 100 years. Right? So we've had these things for a long time. If you take like a business course or something, you might talk about these kind of things. The planning management course probably. Right? All right, so back to the grind here. Polymorphism. We went through polymorphism, subtype polymorphism, function overloading, operator overloading, and then we looked at parameterized polymorphism and then went on to the solid principles. Before we do that, what I want to do is I want to show you a demo. I did a little bit better job of this demo in the earlier section. So what I wanted to do is I want to take this back and show you. I talked about the problem with type erasure before. Let's go ahead and change this to what savings, and then this was an annuity. There we go. So at one point we had an example that looked like this, and it wouldn't compile. Even though we have down here, I have a set of savings accounts and a list of annuity accounts, I was not able to have two functions called sum values that took different types. And this is because of type erasure. In fact, if I hover over this, you'll see the error message here. Erasure of method sum values is the same as another method. So now to understand this, you need to understand the history of Java. I told you that these parameterized types were only introduced in Java 6 or so, right? 5 or 6 years after Java had been born. Right? So what's the problem here? Java bends over backwards to make sure that it's backwards compatible. The way that they introduced this feature is through what's called type erasure. When the Java compiler actually goes through, it does all of its type safety checks and says, yeah, that's a list for savings accounts, great, and you're calling it on a list of savings accounts, great. But when it actually gets compiled, that's how it gets compiled. Let me show you. All right. Let me go ahead and get rid of this so that it actually compiles. Let me get rid of this so that it actually compiles. There we go. Now, when a Java class gets .java file gets compiled, it gets compiled to a .class file, which you can open up and look at. Some of it is plain text, but a lot of it is Java bytecode, just a bunch of binary that you're not going to make heads or tails of. But check this out. Where's our sum values? Right, there it is. Do you see any typing here at all? Nope. In fact, it's actually also changed my code significantly because the compiler is a better coder at lower level stuff. right? It erased it. And that was the compromise. That was the great compromise from Java 5 to 6 when they introduced this stuff. Or maybe it was 4 to 5, I forget, where they introduced collections. The way that they did this was by erasing the types. And so consequently, if you erase the types, how can you tell the difference between these two functions? After it's been compiled, it looks something like this. Collection and collection. Is there any difference between those two functions at all? Nope. The compiler is not able to figure that out because of type erasure. Undo, 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 undo. Collection, collection, undo, undo. There we go. So there was our ultimate solution, right? We never ever actually use the type T other than it extends accounts so that we can treat them all as accounts. A and A, right? And there. Now we can have any type of accounts. We can have a list of accounts. We could have a set of savings accounts. We could have an array list of savings accounts or whatever, annuity accounts, right? We've got one method here to solve this problem forever. Okay. Then we went on to the solid principles. We only covered the the single responsibility principle. Again, basically, it's good encapsulation. That a class should represent one thing and represent it well. A violation would be a God class, where you put everything into one class. It knows everything, it does everything, it sees everything. You can still violate it by having it do more than one thing. For example, the data converter class, if it was responsible for loading the data and converting it to XML and converting it to JSON, probably don't want to go with that solution, right? You want to separate those out so that ideally your data converter class was nothing more than 6 lines of code. Everything else was shoved off to other classes. Right? You should keep small classes as small as possible. And then, of course, you should also think about Yagni. Even though I said it, I didn't grade anybody in this section, but I've graded at least 30 in 2 other sections. It was not common at all, but we still saw people making, even though we said explicitly, this is wrong, making a name class just to hold a first name and a last name. Right? Don't want to do that. Why? You ain't going to need it. That's bad. That's not good modeling. Right? It's still a person. It's a person's first name and last name. That should go into the person class. Now, if you have a much more sophisticated name class, a first name, last name, middle initial, right? Various formatting of last name, comma, first name, various other behavior, title, right? Doctor, Mr., Mrs., Ms., whatever. A suffix, junior, the third, Esquire, whatever, right? Now maybe you have an argument for making a class to handle all this stuff, right? But if it's just a first name, last name, you ain't gonna need that, right? Avoid leaky abstractions. Don't expose the internal workings of your class to the outside world, right? For example, here's one example that we saw that we didn't doc for, but that I would avoid. Example. Requiring a user to load the person, explicitly load a person's person data file before loading a store file, right? All I want to do is I want to load the store information. I just want to load store data, right? The process of loading store data should fall to that class or function or method or whatever you want to call it, right? I shouldn't have to do things I don't want to do. So for example, if the code looked like this, Java, right? Here's my first version, right? That I want to load up the persons from some class. Data loader, right? Dot load person, or loads persons, right? Then data loader dot load stores, and then list of stores s is equal to data loader dot get stores. There we go. Something like that. Sorry, give myself some more room there, right? That's okay. Or, I mean, this works, right? This breaks, right? What if I just did say, okay, well, I'll load the stores and then I'll load the persons later on because I don't really care about them immediately, right? Suppose that breaks. Why would that break? Well, you need a person as a manager in order to set the manager for the stores, right? What should it look like? Instead, the get stores function should check and make sure these persons are already loaded, right? Or it should be it should be responsible for that, right? That it would be a leaky abstraction to force me to do, oh, before you load up the stores, you have to do this thing, and that thing, and if you don't, then it's just going to throw an exception, right? Why do I have to do all this, right? I just want the store data, right? Just give me the store data. I shouldn't have to do this process, this step. I shouldn't have to worry about that kind of stuff. Single responsibility, right? If it's necessary to load up persons before you load up the stores, that should be handled by a data loader class. For example, I don't care. I'll show it to you. Actually, no, I won't show it to you. Suppose that, because I don't think it's in a state that I can show it to you. Suppose that I had a data loader class. Let's go ahead and just create a new class here. New data loader. There we go. All right. And then I had, say, a list of persons, public static list of person and a persons. All right, there we go. And a public static list of stores, something like this. All right. Bring this in, import this. Fine. Create that for me because I don't have it. Yeah. There you go. So that you don't complain at least. There we go. All right. And you wanted to go ahead and load up the persons, you load up the stores. What are some ways that I could avoid having that problem of forcing somebody to do something else before they did that thing over there? I could have, say, a public void init function where it loads the persons, loads the stores after the persons. Right? And then maybe I don't have this private anymore. I make this private, and then I have a bunch of getters, private. Right? And in your getters, public static list of persons, stores, right? Get stores. Right? You have the logic to check here. Has everything been loaded yet? No. Then init. Right? And then return these stores. Right? And this is just pseudocode, so I'll go ahead and do it like that. Right? That's kind of following what's called the singleton pattern, where this one class there's only one version of this class since everything is static, and you have got this initialization function here. Right? Another way that you could have done it is something we don't cover, is have a static block. Right? Everything in this block is executed when this class gets loaded. Right? It's loaded. It's executed before any main code. It's executed before any other code that that is referring to it. Right? I could put here init. There we go. And then just put I think public static. There we go. And then data loader.init. I could take care of all of that in that static block. Or I could take whatever I put into this function and put it up here into this static block. Anything that you put into a static block is executed once and only once. Only ever executed once. Right? And only once. When the class gets loaded by the Java virtual machine. Right? You are not able to execute this ever again because it's not a function. I can't call data loader dot that static block over there because it doesn't have a name. Right? But that's another way that you could have done it. Right? Yet another way would be like we did it. We had like 4 or 5 or 6 different classes and an interface and a whole bunch of other stuff. Right? Don't get fancy though. Right? All right. Questions on the single responsibility principle? No leaky abstractions. Make sure that everything is doing one thing and does it well. Okay. Let's see, the open-close principle. So it's solid, S-O-L-I-D, excuse me, right? So the O in solid is that every unit that is a module, a class, or a method should be open for extension and closed for modification. And this is just classical inheritance. You put common behavior into the superclasses and make sure that you are able to subclass and change the behavior, but provide that general behavior up above so that you're not changing, that it's not changeable. It's closed for modification. Whatever is defined in the superclass, you're not going to change that, right? Whatever is, in the subclass, you can extend that. You can change the behavior. You can override it in the subclass, right? Again, a violation of this would be putting too much into the superclass. A violation would be, of course, using instance of to determine business logic, right? That is, say, get the value of an account, or more germane to your project. What are you doing with your project? You've got a bunch of items and cost, the cost of items, right? Et cetera, et cetera. In your lab 5, you put the common behavior for taxes up above, and then you overrode that down below so that you could provide specific behavior for a salaried employee, a temporary employee, et cetera, right? But if you put all of that logic up into the superclass, and if I am a certain type, if I am a certain type, if I am a certain type, you're doing something wrong. Now, whether or not you're using an instance of, or another violation that we see, using a string to determine what happens, right? For example, where's my account? There we go. Suppose that this was not abstract. Suppose I did something like this instead. Private, final, string, type. Right? And so what is the type? Type is going to be A for annuity and S for savings. And then over here, I'm not going to use the instance. Brooke said not to use the instance of keyword. All right, so I'm not going to do that, but I'm going to do this. If this dot type is equal to, dot equals A, then we must be an annuity account. I'll go ahead and do something, annuity stuff. All right. Else if this dot type dot equals, what's the other one? Savings, right? Then savings stuff. Right? This violates the open close principle. Why? Because what if I have a brand new account? I have to modify this stuff, and the superclass is closed for modifications. Right? You should not be doing this stuff. This means that I have to rip open the superclass and change it and modify it. Right? If I'm going to do this, I need to allow it to be open for extension in the subclasses. The subclasses, of course, would be, say, annuity over here. We've got that get value method that simply just does the math for you. Right? So this one would be a violation of this. Right? Yeah, you did it without having to use the keyword instance of, but you're still doing it using these types here. Okay, that would be a violation of the open-close principle. Another tip here would be have a good, well-thought-out inheritance hierarchy, because it's extremely difficult to change it later on. Imagine if they didn't design this hierarchy in the collections library well in Java, right? It would all come tumbling down 20 years later, because you're either going to be fighting this for 20 years or you're going to not use it because it's not as flexible, right? It's not extensible. It's not open for modification. So we just go ahead and jump into the Java code itself. And anytime we want to make a change, we have to jump into the Java code itself, right? No, right? If I want to define a brand new type of linked list or something, I can do that. I can extend it without mucking up anything in this hierarchy here. Right? Have a well thought out design, right? Another example would be the integer class. Remember, it was made final. You cannot change it, right? That's actually closed for modification, right? Because I don't want you changing plus to minus and subtraction to multiplication or something, right? I don't want you to change what an integer is. So using a final keyword prevents you from doing that. Think about that in your design document this week on what belongs in the superclass, what belongs in the subclass. Basically, if you just go through the same process that we did here and just think about it, like, okay, I see some commonality. What is that screaming out to me? Promote it. Right? I see some specialization. but I don't see any way of implementing it up here without returning some flag value like 0 or null. Make it abstract. Right? Just follow those ideas. The Liskov substitution principle, that is basically saying that, let me quote it here, if S is a subtype of T, then objects of type T may be replaced with objects of type S without altering the desired properties of T. And that simply means that if you've got an array list and a linked list, you can treat them both like lists. This is just subtype polymorphism. Right? A violation of this would be that rectangle square problem. Do you remember that? So we had a class shape, rectangle, and square. Why? Is a square a rectangle? Yes, always. Right? And a rectangle is a shape. But what happened when we added setters, where we took a 10 by 10 or a 5 by 5 square, and I changed it so that now it's a 5 by 10 square? Is that a square? Not semantically, but it's still a square because of my typing system. Right? That's a violation of the Liskov substitution principle. And I don't have an OOP pre-prepared video series, but I do have a suggestion on a video of Barbara Liskov giving a little bit of a history of how they came up with it in the 80s. And I mean, it's one of those mathematical things that once it's there, you just take it for granted. Like, yeah, that's obvious. Right? It wasn't obvious for the first person that came up with it, right? I mean, we take the wheel, right? Well, yeah, that's obvious, right? It goes with the least amount of friction, right? Some caveman somewhere had the stroke of genius to make a wheel first, right? And then once everybody saw that, yes, of course, right? And so the Liskov substitution principle is something like that, right? It's really obvious and simple in hindsight, but they were going back and forth, like, how do we define this? Like, what is the mathematical way of defining something like this? And she goes through a little bit of the history of that. Right? The interface segregation principle simply just says keep your interfaces small. Right? That no client code should depend on things that it does not care about. Okay. So for the example that I usually go to here is an on-click event handler. You're designing a graphical user interface, and you make a button that says save. Right? When you click that button, on-click, you've got code there to actually save the file. Great, everything works. But what if this click event handler is an interface that defines two methods, on-click, on-double-click? Do you usually in an interface on a button, do you usually double-click a button? Yes, no? Oh, do we double-click? I thought my grandparents were the only ones that double-clicked buttons. Do you usually double-click a button? You double-click a file to open up a file, but do you double-click a button? No. In fact, it's caused so many damn problems that if you look at the grader, I disabled that stuff. Because if you double-click the grade me, and I don't do anything about CSE. Let's see. Grade. Here, I'll grade myself. Now I have to log in, damn it. Is that my there we go. All right. There we go. So grade me. Should I double click this? If I did, what would happen is I send 2 requests to the server, right? And then they'll have a race condition where whoever gets done first reports back. And then if they get done right away, the second one gets done right away, it refreshes again, right? I didn't do that. Right? I didn't hand anything in. But did you see what happened to the button really quick? It grayed out a little bit. Right? That's a feature that I had to add when too many people were double clicking. So maybe I'm wrong. Maybe people do double click a lot of stuff, right? But anyway, going back over here, no, I don't want to design it that way, right? But I'm forced to. I'm forced to because this interface here defines 2 methods. So what do you do with the double click method? Right? Throw an exception. This is not supported, right? That's one way of doing it. Do nothing. That's another way of doing it, because when you double click, you click, and then you have another click. And so this event gets registered, and then this event gets registered after it. So we're saving the file anyway. Right? And then over here, we'll just do nothing. Right? But I had to write code explicitly saying do nothing because of this. Another way of doing this, so if they double click it, we'll go ahead and call on click. Right? so I don't repeat my code of actually saving the file. I got myself into this problem by having a large interface with two methods. Keep it small. Why should I have two methods here? Just one. If you want to handle both of these things, fine. Implement the click event handler and the double click event handler. And now you've got your two methods. Multiple different methods, or multiple different interfaces. That's what they did here, right? They segregated out everything into different interfaces, small interfaces, so that you could go ahead and mix and match. I want that one, I want that one, I want that one. I'm going to go ahead and mix them all in. Right? But each one of these only defines 1, 2, maybe 3 methods at most. In fact, some of them don't even define methods at all. Random access, there's 0 methods, 0 state in there at all. It's just saying that an array list, you have free random access with this thing. You do not have that with a linked list, and so it doesn't implement that interface. Right? We'll take a look at that later on as well. Right? But anyway, keep all interfaces as small as possible. That's the design principle with the interface segregation principle. Right? For yours, I don't even know if you want to define an interface. If you do end up defining an interface, go ahead, great. But if you do, make sure that it's small, like 1, 2 methods at most. Right? All right. The last one is the coolest, dependency inversion principle. High-level modules, classes, should not have to depend on low-level modules. We're about ready to get into database programming, so consider the following. You write code, example. You write code that connects to a MySQL, a free MySQL database. Great. Right. With very specific MySQL methods, etc. Right. Now it changes. Now you change. You've grown, right, as a company, and need to migrate to MS SQL. MS denotes what? Microsoft. So, here's a good question, since we have time. How do you pronounce that? Or how do you pronounce this part of that? Anybody? Squirrel? Okay. There we go. All right. I remember you were at Sandhills, thank you. And they're probably a Microsoft house, a .NET house, right? And so that's called a shibboleth. So what's a shibboleth? It's a Hebrew thing where various different tribes, Hebrew tribes, they have different ways of pronouncing the same word, right? So for example, that can of, do I have one? No, I don't have any drinks right now. But if I had a can of what in my hand? Like, so say what? Soda, right? Anybody else? Pop, right? That's a shibboleth. That kind of tells you where you're from in the United States. Word usage or pronunciation. So this is a shibboleth because I knew immediately you were from a .NET house or a Microsoft house because they come from, they all pronounce it SQL, right? If you're coming from a MySQL background, how did I pronounce it? SQL, right? Why? Because it's an acronym, Structured Query Language, right? And so it's a shibboleth. I can tell that you started out looking at databases from a Microsoft point of view versus a free and open source SQL point of view, right? Anyway, now you've grown as a company, and we need to spend a few $100s on a SQL server, right? So what do? Guess what? That very specific MySQL code now gets thrown away. Throw away all DB code and connect to the MS SQL server. Right? In other words, you rewrite everything. That's if you are not going with the dependency inversion principle. Instead, what should have happened? Instead, you should have written generic code for an interface that each one of the databases implements. In other words, we're inverting the dependency. Here's a picture of it. Right. This is just the first one I pulled off the internet. Right. Without dependency inversion, we write objects, we write our database code to connect to a very specific type of object B over here. Right. That locks us in. If we need to change this so that it now relies on object C, we throw everything away, start over, rewrite everything. With dependency inversion, what we do is we don't write our code that depends on that one thing. We write it so that it depends on an interface. Right? We're not dependent on object B anymore. We're dependent on the interface. Object B is responsible for implementing that interface. They call it inherits here. Implements is the keyword in Java. Right? Now, how does this solve my problem? If we want to switch over from MySQL to SQL Server, all I need to do is take this package over here, throw it away, and drop the package provided by Microsoft. I don't have to change a single line of code over here in my code that's connected, in my application code that's connecting to the database, because I've got an abstraction line between them. Right? Here's another example. Let's see, how much time do we have? Yeah. Here's the example that I was working. Here, I'll give you two examples actually. So say that we've got three libraries here. Example. Say that we've got three libraries here that all do GPS location stuff on an Android phone. Right? The first library gives you these two methods, get latitude and get longitude, right? And they both return doubles. I don't know, 0 or negative 180 to 180. Right? Library B, Android location, gives you a location object. From that location object, you can go ahead and get the latitude and longitude. Same, negative 180, positive 180. Right? And then we've got another library that relies on cell phone tower triangulation. Cell phone tower GPS.get latitude, but in radians instead of latitude, longitude, degrees. Right? What am I going to have to do? I'm going to have to write code that looks something like this. Right? If I'm using library A, then I will go ahead and create a new location. This is Java. New location using the get latitude, get longitude. Otherwise, if I'm using library B, I'll have to go ahead and get that location and then pull out the latitude and longitude itself. Right? If I'm using library C, then I have to do a whole bunch of stuff. I have to, there we go. There's the whole thing. I have to get the latitude and radians and then convert it using a utility function here to degrees and a utility function to degrees for the longitude. Right? If, else if, else if, else if, else if, else if. I have to do different things for the way that different libraries handle this stuff. How could I invert this? Inversion. Right? What I'll do is I'll go ahead and create a interface. Right? Public interface. Drop down. There we go. Public interface, get location. There we go. And there is one method, or I shouldn't call it get location. What should I call it? Locator? Not GPS locator because it's not necessarily GPS. Locator. There we go. I'll just do it like that. Public location, get location. Now what I can do is I can rewrite all this code up here, if, else if, else if, else if. I can take each one of those three cases and I can put it into a different class that implements that one interface. And then I will have one interface to worry about. Give me that location. I don't need to worry about the details of converting those radians over to degrees or degrees to radians. I don't have to worry about, well, which one was the actual function? Oh, this one gave me a location that I then need to change into a different location because this is an Android location, that gave me two numbers, so I need two function calls, right? I don't need all of those details. I take those details and I put them into classes, right? For example, I could have, say, public, Android locator, right? Implements locator. Right, there we go. And then I could have a public location, get location method. And what's it going to do? It's going to take that code and put it right there. Right? So Android location, get location, and then I return a brand new location based on that, right? And my client code, later on, client code, doesn't care about the type of locator. Oops. No parentheses there. Instead, I just have locator, L is equal to new Android locator. There we go. And then I go L.getLocation. Location equal. Right? Now all I have to do is change instantiation. All of the details are hidden inside of that class. Now it might seem kind of trivial because each one of these was at most 2 lines of code. But think about a database. Is a database going to be 2 lines of code? No. So you'd have, if you went with this kind of solution for something that looks like this, right? Each one of these blocks of code is going to be huge, right? And what you should be doing is you should be taking that and offloading it into another location, into another class. Right? Inverting here is kind of a bad term, I think. Inverting a dependency doesn't mean that you're taking this. This thing depends on this thing, and so we're going to invert it like this. The dependency becomes the dependent and vice versa. It's a bad terminology because that's not what you're doing. This thing depends on this thing. So what I'm going to do is I'm going to separate them out side to side, and then they're going to speak through this interface. Right? That's the way that it should be looked at. I don't know why they call it inversion. Right? You're not really inverting it. The dependency doesn't become the dependent and vice versa. Right? Anyway. In general, you should prefer basically loose coupling, right? You should be able to take out component, this component, this component, this component. You should be able to take out this component and replace it with a completely different component without affecting these other components over here, right? It's kind of like any machine, right? Should you be able to, you built this large machine that has many different moving parts, and you decide, I don't like that brand of motor anymore. Right? Take that motor out and throw it away and put a new motor in there, right? With the same specifications, same RPM, same power source or something like that, and everything else works, right? This is how cars are designed, right? You don't design one car and that's it, right? You design this one car that can use that kind of tire and that kind of chassis and that kind of motor because they're going to manufacture millions of those motors for multiple different types of cars. Right? I don't know anything about cars, so I assume that's true. Yes. Certainly, you don't have to go to the Honda store and get Honda tires on your car. You're not locked in like that. But believe me, companies would love to be able to do that. And then you're at their beck and call for every component of the car, right? And that's not good, right? John Deere is notorious for that, right? They've locked down everything with DRM now, right? That's the right to repair movement is passing laws to prevent that kind of anti-design. Right? All right. Any questions on object-oriented programming? Because that's the end. There are a couple of other acronyms, but it's basically the solid principles restated because somebody has a new bright idea and they need to restate it so that they get credit for that new idea when no, that's old. Right? That's been done before. Right? Otherwise, what you should do between now and Wednesday, in addition to phase 2, is you should go to cse.unl.edu/account, log in, using your CSE credentials, not your MyRed or anything credentials. If you go over here to account settings, it'll look a little bit different because I've already got my SQL password, but it'll look something like this. You can always come back here and reset it, right? And it'll send you a new email on your new password. Do not use a password that you care about, right? Because if you're teaming up with somebody, you're going to probably be sharing this password as you develop. Certainly, this password will then appear in your Java code because eventually you're going to connect to the database. So don't use a password that you care about. Mine, it's usually just auto-generated alphanumeric code. You can go ahead and change it if you want to something more readable, but don't change it to something that you use a lot. FAQ. Oh, wow. Okay. Where's our system FAQ? Undergraduate. FAQ. There, support FAQ, FAQ, and MySQL database account requesting and connecting. There we go. MySQL password. Oh, there we go. It should be embedded somewhere in there. Connecting and then changing your log. I'll show you how to do it here in a moment. But anyway, you need an account, right? Unless you want to set up your own SQL server, SQL server, whatever, right? Then you're going to be using the CSE server. Then what I would suggest is that you go and download MySQL Workbench. Is it the best? No, but the price is right. It is free, right? It is a product put out by MySQL. MySQL is owned by Sun. No, not Sun. Not IBM. Who is it? It's owned by, what's the other big database company? Anybody? Not Microsoft. It's Oracle. Thank you, Oracle. Oracle owns it now. Oracle owns Java as well. That's why I was thinking Sun Microsystems, because they bought Java from Sun. But anyway, download now. Note, if you are a Mac user, I would suggest not this version. Instead, go with the previous version. I could not get 32 to work. Every single time I executed a query, it crashed. So I would go with 8.0.31 for Mac versions. For Windows versions, if it works, great, right? If it doesn't work, then go to an archive, maybe back a couple of versions or something, right? Anyway, what it looks like is, let me start it. It looks like an IDE, right? Because that's what it is. But it's for SQL stuff. You can do this stuff in Eclipse if you want to just stay in Eclipse. I do it over here because it's a little bit fancier, right? But you can go ahead and create a connection. Your connection, call it whatever you want, CSE, because that's what it is. It is located at cse.unl.edu. Port 3306, that's standard. Do not change that. You are not root. I am not root. The only root people are those that work in the basement over in Avery. They are not going to give you root, right? Root is the super user that can do anything. You are you, and I am me, right? I've already got that connection up and running here. My password has already been set and saved. I'm going to go ahead and use my database, and I've already got some tables in there. Ooh, that looks familiar. Let me go ahead and get rid of that. Right. I'm going to have to install some stuff because we're going to be using a video game database. But otherwise, you can start using SQL, right? And it has, that should look familiar at least, right? Stacy query, Nona, Micoletti, Whit, Leovold, right? That's our test case, right? Do you think I wrote that? No, I auto-generated it, and I also generated the code to put it into a MySQL database, because I didn't want to have to write that crap. But there it is, right? So you can go ahead and execute commands directly in MySQL Workbench. And we'll get started on that on Wednesday. Right? Otherwise, I'd recommend installing this as soon as possible. If you want to use something else, that's up to you. Right? Questions? Oh, well, okay. I don't think there were any. There were just comments on the chat. No questions. All right, but if you do have a question, go ahead and post PIs afterwards. Right. Otherwise, I'll see you on Wednesday.